Hi students, myself D.K.Narale, working as an assistant professor in Gopal Krishna Gokhale College, Kolhapur. Today going to discuss Chelation, B.Sc II Semester 4, Chemistry paper number 7, topic number 2nd. Outline of this topic is first point in this topic a brief introduction with respect to ligand, chelating agent, chelation and metal chelates. Second point structural requirement of chelate formation. Third point difference between metal chelate and metal complex. Fourth point classification of chelating agent with specific illustration of bidentate chelating agent. Fifth point is application of chelation with respect to chelating agent EDTA, ethylene diamine tetraacetate acid, DMG, dimethyl glyoxime. Introduction of this topic. Metal chelate have wide application in detergent, medicine, antioxidant, dye, water softening, chemical analysis and food preservation. Used in the various industries. Some important terms in the chelation ligand. First, it is donor species which can donate an electron pair in central metal atom or ion during the formation of complex or coordination compound. Ligands are classified into two types. Main unidentate ligands are also known as monodentate ligand. Monodentate means teeth. In this monodentate ligand contain one lone pair electron donation. In polydentate ligand, second type, bi, tri, tetra, penta, hexa. That ligand contain donor atom is 2, 3, 4. Mostly unidentate ligand form only complexing agent, but in polydentate ligand form chelating agent, that is ring formation compound, heterocyclic ring formation compound. Chelating agent or ligand, bidentate or polydentate ligand. Bidentate means it contains two donor atom, polydentate means many donor atom in ligand, which attached through two or more donor atom to the same central metal atom or ion, forming heterocyclic ring, is called as a chelating agent or chelating ligand. Example, EDTA, ethylene diamine tetraacetic acid and dimethyl glyoxime. Metal chelate, it is defined as formation of heterocyclic ring by the association of polydentate ligand with central metal atom or ion. This process is called chelation. Reaction, metal ion plus chelating agent to form a metal chelate. The formation of heterocyclic ring containing metal atom which being linked by either coordinate or covalent or both type of bond with two or more non-metal atom in the same species is known as chelation. Structural requirement for the chelate formation. First point for chelation formation is chelating agent should have donor atom which can donate lone pair of electron to metal easily to form a strong bond. Generally, donor atoms are the nitrogen, oxygen, phosphorus, sulfur are the donor species. These donate electron to central metal atom. Second point, chelating agent must contain donor group formation stable ring. Examples, amide dash NH2, oxime dash NOH, amino group dash NH, acid group, carboxylic acid group, sulfonyl group, enol group, thionyl group, etc. Third point, essential heterocyclic ring between chelating agent. Formation of the ring metal with a chelating agent to form a chelating heterocyclic ring between the chelating agent and central metal atom or metal atom. Fourth, the chelating agent possesses at least two donor atom. That is, ligand contain at least two donor group. Fifth point, this should not be substitution of bulky group on the donor atom as its steric hindrance. On ligand, substitution of bulky group on ligand, then the steric hindrance is formed. That's why donation of electron is and ring formation is form a steric hindrance. Sixth, the size of the chelating agent proper to avoid steric hindrance. Size of the chelating agent proper to avoid steric hindrance. There is no substitution on ligand by bulky group. 7 point, metal ion should have adequate size, higher charge and suitable vacant d orbital. Metal contain vacant d orbital, also size charge on metal is high, then the form a stable metal chelate ring. Difference between the metal chelate and metal complex. Metal chelate is the association of metal atom or ion by forming heterocyclic link with polydentate ligand. It contains polydentate ligand, but in metal complex may be defined as the association of metal atom or ion with monodentate ligand. Monodentate ligand is called complex formation, that is metal complexes, but here polydentate ligand greater than one donor atom in the ligand, then the form of metal chelate. Second point, approaching ligand are always polydentate, that is di, tri, tetra. Ligand contain 2, 3, 4 donor atoms. But in metal chelate, metal complex, approaching ligand are always unidentate. It contain only one donor group. Third difference, the nature of the chemical bonds are essentially either coordinate or covalent or both types. Similar, the nature of chemical covalent bond are essential coordinate, only coordinate bond form. Fourth point, it has high stability because of the ring formation. Ring formation compound are more stable than the simple metal complexes. Relatively, it has low stability. Fifth point, the charge on the metal ion is relatively large with suitable size. Metal contain the orbitally vacant with a higher charge, then the form stable metal chelate. The charge on the metal ion is relatively low with suitable size. Sixth, even in solution they dissociate negligible. In solution they metal chelate are dissociate negligible, but in comparatively the dissociate more in solution by metal complexes. Last point, they may or may not have regular shape, but here they have generally regular shape. These are the difference between metal chelate and metal complex. Application of chelation. Recent discoveries have well proved metal chelate play an important role body metabolism and plant process. Example, photosynthesis, hemoglobin, enzyme action, etc. Also, it has broad spectrum of application in different fields such as medicine, detergent, dye, food preservation, water softening and purification, analytical chemistry and research activities. The important application of chelation with respect to EDTA and DMG discussed below. First, EDTA, the structure of EDTA, ethylene diamine tetraacetic acid. As a chelating agent, EDTA has very important and wide application in analytical chemistry. It is always used as it's a disodium salt due to its high solubility in water. It possesses strong chelation power and form a chelate with most of the metals. The important uses of EDTA discussed here. Donor atom 1, 2, 3, 4, 5, and 6. That is, EDTA is hexadentate ligand. Sixth donor atom. First application, removal of dissolved salt of iron from water supply. The presence of iron in water, decoloration bathtubs and lines. Second, form sediments on standing, also spoil the taste of tea. Use of EDTA prevent the ill effect of iron without its removal from water. The dissolved disodium salt of EDTA in water form every stable metal chelate with ferric ion containing 5-membered ring. The first removal of dissolved salt of iron from the water by using EDTA. Second, to prevent metal ion formation, form precipitation. Citric, malic, and lactic and tartaric acid are among nature's chelating agents. They keep the metal ion away from precipitation in body fluids. In the same way, EDTA prevents precipitation of iron from well water and body fluid. Most important use of the EDTA in the functioning of the body fluid and water. Third point, water softening. It is done by adding sequestering agent, that is the chelating agent, forming water soluble chelate which is combined with Ca2 plus Mg2 plus, that is water contains Ca plus and Mg2 plus, known as the hard water ion, to form water soluble chelate. The water becomes soft, and the most widely used sequestering agent is EDTA. Dissolve the Ca2 plus and Mg2 plus in hard water by EDTA. Next, fourth, food preservation. It is our common observation that cut apples become brown in color, fats and oil become rancid, orange juice loses its flavor on keeping and on standing, green vegetable vitamin C get spoiled as trans of metal ion present in the catalyze effectively the atmospheric oxidation. The addition of EDTA form metal chelate prevent the damage and it's improve the keeping qualities of such food to a great extent by oxidation of cut apples juice, keeping in long time, then adding the EDTA, their oxidation is atmospheric oxidation is stopped, and these food are quality use for next time. Fifth, to evaluate total hardness of water. The known volume of hard water sample, that is Ca2 plus and Mg2 plus ion, is titrated against EDTA solution using Erichrome black tea indicator, and hardness of water can be determined by using EDTA solution. Some other applications, to detect and estimate the trans of copper in steel by using EDTA and dithiocarbamates. Second, in separation and purification of lanthanide radioactive metals, etc., principle of chelation is used. Separation and purification of lanthanides and radioactive metal EDTA are usually in the separation of purification of lanthanide and radioactive metal. C. In qualitative and quantitative analysis, chelation play important role as follows. First, EDTA is widely used for the estimation of almost all metal titrametrically. Example: aluminum, iron, cadmium, zinc, copper, cobalt, Hg, mercury, Pb, Cam, Thu, uranium, etc. Second, certain anions such as sulfate, arsenic oxides, fluorides, hexacyanoferrate, 2 phosphate ion, chromium tetroxide ion are the used quantitatively and qualitatively separation of these ion by using EDTA. Third, most of the commercial material like alloys, ores, rocks, petrol, ethers, cement, minerals, oil, paints, sludges, etc. can be analyzed by using EDTA solution. Next, it can be used effectively as masking agent in the most of the reaction. To mask means to lock. EDTA mask many metal ions and thus widely used in analytical separation and extraction. D. In medical field, it can be used as medicine to treat copper and lead poisoning, removal of radioactive metals from the body fluids. Creams containing EDTA are used to treat skin disease like dermatitis. Second uses of DMG, diethyl glyoxime or diacetyl dioxide. It contains two donor atoms, this bidentate ligand N and it has discovered by L. Tunchuk-Deep in 1905 and was used by Brunke in 1907 for the determination of nickel in steel. It is insoluble in water but dissolved freely in alcohol. The important uses of DMG can be summarized as Ni2 plus DMG ammonia then form a complex with 4 nitrogen 2 molecule of DMG with complex to form a nickel complex with nickel chelate. Uses of the titrifene sample solution is acidified and treated with 1% alcoholic solution of DMG in presence of ammonia alkaline medium. The formation of scarlet red color needle-shaped crystal indicate the presence of Ni2 plus in the given sample solution. Second, DMG as a spot test reagent. As it is specific reagent of nickel, it is used in qualitative analysis as spot test reagent. Here, sample solution is treated with drop of 1% alcoholic DMG on spot paper and the paper is exposed to ammonia vapors. Appearance of red spot indicates the presence of nickel sensitivity. Part 1 nickel ion is 20 lakh parts of water. Estimation of nickel. First, a gravimetric estimation of nickel. Nickel solution is first acidified, boiled, and 1% alcoholic DMG in excess is added to precipitate nickel scarlet red precipitate in presence of ammonia to form a precipitation. The solution is heated for some times and cooled. After an hour, it is filtered, washed, dried. 100 to 120 degrees Celsius. Weight and amount of nickel is calculated by using relation weight of residue is equal to weight of the residue plus 0.2032. In this precipitation, scarlet red precipitate is formed and the filter by using Gooch crucible, and weight of residue is calculated after calcine or dry. Second B, volumetric estimation of nickel. The precipitation of Ni as NiDMG chelate is washed and then dissolved in 20 normal H2SO4 solution. The solution is boiled and treated with 50 ml of 4% ferric sulfate solution. Then it is heated, cooled, diluted by water and 3 ml H3PO4. It is titrated against a 0.1 normal KMnO4 solution, and amount of nickel is calculated by using the relation 1 ml of 0.1 normal KMnO4 is equal to 0.000733 gram of nickel. By titration, volumetric estimation of nickel by using titration method. Next, calorimetric estimation of nickel. Here Ni2 is oxidized to Ni4 by bromine water. Then it is treated with DMG in ammoniacal medium so as to produce intense red color, which measure the calorimetrically. Thus, it is sensitive, selective, and special region for the nickel, and calculated by the calorimetrical by nickel by using the DMG in ammoniacal solution. Next, gravimetric estimation of palladium. Palladium is precipitated as yellow colored complex by using DMG from dilute mineral acid solution and estimated. Thank you for listening and watching.